There we go. How are you doing, students? It is Sunday night. Welcome to Mr. Rich Q&A. What I'm going to do tonight is start off by showing you what you need to know for matrices on the ACT. Most of the students in our area are taking the ACT in class in their school on February 24th. Quite a number of them did take it probably this past Saturday as well. But what I wanted to do is go over what matrix problems look like on this ACT. So most students around here, at least in this part of Florida, their Algebra 2 class did not cover matrices, but it is something that you could expect on the test, one question, sometimes two, but probably now in the enhanced version of the ACT, you're not going to see two questions on matrices. So let me just show you some of the operations that are involved with matrices, what you need to know, and then we'll look at a few example problems. Now, if you are joining me live, you can submit math questions to me with the email that you see scrolling along the bottom. I'll check that email here in about 10 minutes when we get done with this first presentation about matrices. All right, so first of all, what I'm going to do is just show you what a matrix is. A matrix is going to be a group of numbers that are going to be in between brackets. Now, to do these problems on the ACT, you don't really need to know why we use matrices, like in real life, and what they're useful for. You just need to know how to do the operations. But what they're used for generally is to solve systems of equations. But you really don't need to know that to know what I'm about to show you. So I'm going to make a matrix that has these four numbers in them, right there, in between brackets. So that right there is a matrix. And what we do, first of all, is we classify matrices according to their dimensions. So when you take a look at this matrix, we are going to look at how many rows it has. So if you look right here, it's got 2 rows. Now I'm going to move my head out of the way, out of this shot. Let's move it. Yeah, we'll move it over here. In fact, I think I'll just do this right here. Okay. Now it has 2 rows and it has, as you can see up here, 2 columns. So what we do is we call this a 2-row by 2-column matrix. It's 2 by 2. That'll be important here. I'll show you in just a few minutes why we want to classify what the dimensions are of the matrix. But if I have this matrix, and let's call it matrix A. A lot of times they will assign a capital letter to name the matrix. If I tell you to take 4 times matrix A, then you would probably assume that you would distribute that 4 to each one of the elements inside the matrix. And if you assumed that, you would be assuming correctly. So this would end up being 4 times 7, 28, 4 times the -1, -4, 4 times 5, and 4 times 6. And that matrix would be the matrix 4 times A. Now I'm going to define another matrix. Let's call it matrix B. It's going to also be a 2 by 2 matrix. It's going to look like this. It's going to look like that. Now, one of the things that you may see on the easier portion of the ACT towards the front, questions 1 through 30, is they may ask you to do something like this. They may say, given these 2 matrices, A and B, calculate 4A minus 3B, something like that, where they multiply the matrices and then tell you to add or subtract them. Well, this matrix here is a 2-row by 2-column matrix. And so therefore, once I multiply it by 3, let's put that over here, 3B is going to give me also a 2 by 2 matrix. It would be 0, -21, 9, and 18. If I'm going to subtract 4A minus 3B, then what I would do is I would take all of the corresponding elements from matrix A, from matrix 4A, and subtract them from the corresponding elements over in matrix 3B. So therefore, this matrix is going to be a 2 by 2, where I will take then 28 minus 0, -4 minus negative 21. That would be negative 4 plus 21. That would give me a 17. 20 minus 9 is 11. And 24 minus 18 is 6. And so I get another 2 by 2 matrix. So those are some of the operations, basic operations that they may want you to do on matrices. Now, let me show you one other thing that involves a 2 by 2 matrix. If I give you a 2 by 2 matrix, 7, 4, negative 1, 3, I could ask you to find the determinant of that matrix. Determinant of the matrix. And we'll call this matrix C, the determinant of matrix C. Now, what is the determinant of matrix C? It is where you take the first diagonal product here of the matrix. You're going to take 7 times 3, and you will take away the other product, the other diagonal product right here. So that would be 4 times negative 1. So that would be 21 minus a negative 4. The determinant of the matrix is 25. And then that 25 is the determinant. So that's definitely something that you would not know. If someone hadn't told you, like I've just told you what that determinant is, you would not know that you were supposed to take, the two diagonal products and then subtract them from one another. But that is something that you could be asked during the ACT test right there. All right. The next thing that I wanted to show you is how to multiply matrices. Now, here is where the dimensions are going to be important. So what I'm going to do here, students, I'm going to give you a 2 by 3 matrix. I'm going to give you negative 1, 0, 3, 6, 1, and 5. And this is a 2 by 3 matrix. Remember, we take a look at the rows, which there are 2, and we take a look at the columns. There are 3 columns right there. So this is a 2 by 3 matrix. Now, what I'm going to do is I'm going to multiply it by a 3 by 2. So I'm going to make a 3 by 2 matrix that would be the following. Like that. And that is a 3-row by 2-column matrix. Now, the thing that you need to know first about multiplying 2 matrices is that not all matrices can be multiplied together. The way that you know whether matrices can be multiplied is you take a look at their inner dimensions. I'm talking about this number of columns of the first one, 3, and this number of rows of the second one. In order for the multiplication to even be performed, for it to be a viable value, to actually an operation that you can do, is these two need to match right there. You need to have the columns of the first match the rows of the second. So as long as those two do match, then that means that you can do the multiplication. And then these two outer dimensions are going to be the dimensions of the resulting matrix after you do the multiplication. So this is going to result in a 2 by 2 matrix. Now you may wonder, how could you multiply a 2 by 3 by a 3 by 2 and the result is a 2 by 2? Well, I'm going to show you how you do the multiplication. But the first thing that you need to know is that the result is going to be 4 numbers. Right? I'm going to put a number in each of these spots right here to make a 2 by 2 matrix after I do that multiplication. So the question is, how would you do the multiplication? So here's how you do it. And I always tell my students, if someone hasn't shown you how to do matrix multiplication and you get on the test, I could give you 2 hours, you would not figure out the way to do it. It's not really common sense. It kind of does make sense after you understand how we use matrices, but just looking at these numbers, you would never know. What you're going to do is you're going to take this first row of the first matrix, negative 1, 0, 3, and you're going to take it and basically rotate it to make it into a column. And you're going to then multiply it by the first column of the second matrix and multiply the corresponding elements that line up. So this would be -1, 0, and 3. So when I take this first row and I match it against that first column of the second matrix, I'm going to do the multiplication, the product of each of these pairs, and then add them together to get a single number. So this would be -1 times 1, which is -1, plus 0, plus 27. So that's 26. So the very first number that goes into my answer is the number 26. Then what you do is you take that same column that we generated from the row of this first matrix, and you're going to repeat that by multiplying each of the corresponding elements times the second column of that second matrix. So this would be 0 times -1, which is 0, plus 7 times 0, which is 0, plus 3 times 3, which is 9. And that goes there. To figure out what goes in these other two spots, you're going to move now down to the second row of this first matrix, 6, 1, 5, and you're going to then multiply and repeat pretty much this same procedure. You're going to multiply those corresponding elements in that first column of the second matrix. And when you do the products, you're going to add them as you go. So this is 6 minus 7, which is -1. -1 plus 45 gives me 44. Then I would take those same three numbers, 6, 1, 5, and I'm going to multiply them here. So that is, let's get rid of these and replace them. So I'm multiplying 6, 1, and 5. So 0 times 6 is 0, plus 7 times 1, plus 3 times 5. That's 7 plus 15, 22. Okay, and then that is the resulting matrix of the multiplication of those two matrices. Okay, that's how you do it. Now, let me show you a few problems from the ACT that involve matrices. So let me do that. I am going to do this right here. So hang tight while I go grab what I need to. We're going to look at some practice tests from the ACT. And I don't have these ready to go, so just hang tight while I pull them up. Just take a few seconds here. Yeah, so we're going to just take a quick look at it. I got all of pretty much every single ACT practice test that they have used. I have got them pulled up here. So what we're going to do, these are some of the older practice tests back before the enhanced version when they were doing 60 questions, 60 minutes. Okay, so we're going to go and we're going to find a matrix problem. And I apologize, I don't have these lined up and ready to roll. So this is a practice test. We're scrolling through, assuming there's going to be a matrix problem on here. And let's see where that would be. We're running out of time here. Well, strangely enough, that one, there was not a matrix problem. Not to worry, we're going to find one. And here we go. So here's one. So this is a good one to cover because this would be one that would appear towards the end of the test. Questions 31 through 45, the last 15 questions of their enhanced version. You could expect a more challenging matrix. This is matrix multiplication here. It says, in this park, the average number of gallons of water consumed per day by each elephant, lion, and giraffe is 55 and 10 respectively. So elephants are consuming 50 gallons per day, lions 5 gallons, giraffes 10 gallons. Which of the following matrix products yields an average total number of gallons of water consumed per day by all the elephants, lions, and giraffes in the park? Well, let's consider what the dimensions are of each of these matrices. This right here is a 1 by 3. This matrix here is a 3-row by 1 column. If I were to multiply these two matrices, as I was showing you before, I can do the multiplication because I can do them because of these inner dimensions matching, but the result would be the outer dimension. So it's going to be a 1 by 1 matrix. Well, a 1 by 1 matrix is just a single number. And that's actually what I'm looking for in this problem because I want to get a total number of gallons for all the animals. So I do want a 1 by 1 matrix. This one would also yield a 1 by 1 matrix. Now, these multiplications that are going on over here, this first one is a 3-row by 1 column matrix, and then I'm multiplying that by a matrix that is 1 row by 3 column. And so that result would be a 3 by 3 matrix. These inner dimensions are going to match, which means the result would be a 3 by 3. I'm not looking for 9 numbers in this. That wouldn't make any sense. I'm looking for one number to represent all of the gallons that all the animals would consume. So really what that does is it takes out answers C, D, and E. Now on the enhanced version of the ACT, if you've worked any of those practice tests, you know there's only 4 answer choices there. So we got rid of those 3. Now the question just is, have we, I think this is part of a larger problem, is it not? Yeah, it is. So here's the numbers up here. This is the number of each of the animals that are in the zoo. And there's our elephants, and there's our lions, and there's our giraffes. So let's bring those numbers down. So what we have is we have 600 elephants. That must be what the 600 represents. The 200 is the lions, or no, 200, there's 200 lions, and then there's 800 giraffes. Yeah. What is this? This is, it's a 500 square mile national park in Kenya. Yeah, so lots of animals there. All right. But anyways, what were the 50, the 5, and the 10? Those were the gallons per day that the animals were consuming. And so it was the elephant was consuming 50, the lion was consuming 5, the giraffe 10. So if I do this multiplication, what would happen is I would take that one row and turn it into a column, and I would be doing that multiplication. Now, have I lined up the right numbers in this multiplication? Is it right for me to take 600 elephants times 50? Well, yeah, because the elephants are consuming 50 gallons per day. The 200 is my number of lions. I would be multiplying that by 5 gallons per day for each lion. And then I would be adding to that 800 giraffes, and they're each consuming 10 gallons per day. So yeah, this is going to be my answer because it does the right calculation. Because what it would happen here is I would get 3,000 gallons of water for the elephants, 50 times 6,000. Then I would take 200 times 5. That'd give me another 1,000 gallons that the lions drank. And then all of those 800 giraffes drinking 10 gallons per day each, that's another 8,000. So that is going to be my 1 by 1 matrix right there. That's going to be 12,000. Right? I didn't need that number for this problem. I just needed to make sure that these numbers lined up correctly. This is not the right answer just because that when I do the matrix multiplication, I have not lined up the correct numbers of animals with how many gallons that type of animal is drinking. Okay, so that's why we go with answer A. So that is an example of a word problem with a matrix. Let me go to another practice test and pull up maybe a simpler matrix problem for you. And I think we can find one earlier in the test here. So this is number 30 on a test. So here they do give you a 2 by 2 and a 2 by 2. And they said that matrix C is 2A minus 3B. So just as I showed you when we opened this thing up, if I'm going to take 2 times A, I'm going to write the matrix 2A. It's going to be 6, 10, negative 4, and 2. I'm going to make the matrix 3B. 3B would be multiplying each of those elements by 3. So negative 12, 15, 6, and 3. And then what am I supposed to do? I'm supposed to subtract these. I'm supposed to take 2A and take away 3B. So I would do 6 minus negative 12, 18. Already I like answer F because it's the only one that has an 18 in that upper left element there. I'll try this one. 10 minus 15 would be a negative 5. So that checks out right there. And then negative 4 minus 6 is negative 10. 2 minus 3 is a negative 1. So F is our answer right there. And I could probably find one that is a determinant, but don't really need to show you that, I don't think. I'll try one more attempt to see if we could find a matrix problem in a practice test. Scrolling here to see. Doesn't look like it. So far, nothing. Yeah, so nothing there. All right, so that's going to be it for matrices. So that hopefully helps you a little bit to see what you could expect with matrix problems. If you need to work more matrix problems, just look at all of their past ACTs. You can Google ACT practice tests and you'll find, oh gosh, probably 50 or more practice tests in the last 10 years that the ACT has released, and you can look for those matrix problems and practice those. Well, I'm going to check to see if we had any questions come in. It does not look like it. So that's going to be it for tonight, students. I hope it was helpful. Check with me next week, because what I'm going to do next week is I'm going to start off by working some SAT questions. The SAT College Board has released practice test 11 that came out about 2 weeks ago. And I'm going to work some of the harder problems from that practice test next week as we get started in our Q&A. All right, everybody, I hope you have a wonderful weekend and rest of your weekend, since most of you have the day off tomorrow. And I look forward to seeing you here next Sunday night. Take care, everybody.